In this video, we want to find the interval convergence of the sum from k equals 1 to infinity log of k plus 1 over k times x plus 1 raised to the k power. We're going to use the ratio test. So we're going to look at the k plus first term. So basically we just add 1 more for k. So we have k plus log of k plus 2 over k plus 1, x plus 1 raised to the k plus 1 power. So that's going to be on the top, and then we're going to divide it by the kth term, which is what's given already. And then we're going to take the absolute value, and the limit as k approaches infinity. So the nice thing is that x plus 1 to the k plus 1 over x plus 1 to the k is just x plus 1. And we're just going to leave the logs as is for now. Okay. Now at this point, our limit depends only on k. And notice that we have an x plus 1 here. So the x does not depend on k, which means we can bring it outside. When you bring it outside, you want to make sure you keep the absolute value, because x plus 1 is inside the absolute value. And then we just need to focus on the limit of the logs. Note that k plus 2 over k plus 1 is k plus 1 plus 1 over k plus 1. And so you have two separate fractions. The first fraction is k plus 1 over k plus 1, which is 1, and then plus 1 over k plus 1. And then similarly, we have k over k plus 1 over k on the bottom, which is just 1 plus 1 over k. Now, if we let k approach infinity, both of the fractions are going to go to 0. And so we have log of 1 over log of 1, which is just 0 over 0. For that, we're going to use L'Hopital's rule, which says to take the derivative of the top, derivative of the bottom. And here the log, I'm treating it as natural log. It doesn't matter what log it is. It could be log base any other number. But when you take the derivative, the log, you're going to have ln of the base, which is going to cancel with the bottom. So it doesn't matter. So then you take the derivative, you get negative 1 over k squared plus 3k plus 2. And then negative 1 over k squared plus k. The two negatives are going to cancel, and then the k squared plus k is going to go on the top here. So it's k squared plus k over k squared plus 3k plus 2. As k is approaching infinity, we look only at the dominant terms top and bottom, which are the k squares. Those are going to cancel. That's going to approach 1. And so we have the absolute value of x plus 1 times 1, which is equal to the absolute value of x plus 1. And so for the ratio test, we want the limit to be less than 1 in order for it to converge. So now we just solve for x. Now that means x plus 1 has to be between negative 1 and 1. And subtracting 1 from both sides, we get x is between negative 2 and 0. Now finally, what we need to do is test the endpoints. So we need to test x equals negative 2 and x equals 0. So if I plug in, first I plug in x equals negative 2. So you have negative 2 plus 1 to the k is just negative 1 to the k. For this one, we're going to use alternating series test. Clearly, it's alternating. This term log of k plus 1 over k is positive for k being greater than or equal to 1. It's decreasing, and you can show it's decreasing by taking the derivative. And k plus 1, yeah. And also the limit goes to 0. So all conditions are met, and the test or the series converges by the alternating series test. Now we have to plug in k equals 0. So we have 0 plus 1 to the k. That's just 1 to the k. And really, that doesn't do anything. So that's the same thing as saying log of k plus 1 over k. For this one, we're going to use a limit comparison test. So we're going to compare it to 1 over k. And to solve the limit, I will make a substitution. We'll let u equal 1 over k. So as k approaches infinity, u is going to approach 0. And so we have the limit as u approaching 0, log of 1 plus u over u. If I plug in 0 top and bottom, we get 0 over 0. Use L'Hopital's rule. the derivative, the top is 1 over 1 plus u. The derivative of the bottom just 1. Plug in 0, we get the limit as 1. And so when the limit, for the limit comparison test, the limit comparison test, you want it to be finite and positive, the limit. And in this case, because the sum of 1 over k diverges by the p-test, so will the sum, what we were just saying, that also diverges. So this is going to diverge at x equals 0. And so we only include -2 in our interval. So it would be -2 to 0. And that's our final answer.